rational limit again. Let's see what happens if we put 2 into this. You pretty much know it's going to blow up, but let's make sure we're supposed to try this every time. 2 minus root 3 times 2 minus 2 over 2 squared minus 4. 2 minus root 6 minus 4, or sorry, 6 minus 2 is 4 over 2 squared is 4 minus 4 is 0. It doesn't even matter what the numerator comes out to. As soon as you see division by 0, you know you're sunk. This function is not well behaved at 2. So the question is, can we pull this apart? Can we find a way to rearrange this so that it doesn't misbehave at 2 anymore? Well, factoring has helped us before. X squared minus 4 is a difference of squares, which means it pulls apart, in this case, into x plus 2, x minus 2. And you can see how this is the piece that's causing all the trouble. When you plug a 2 into this, it goes to 0 and it takes the whole expression down with it. But how do we cancel it? We don't have an x minus 2 in the numerator right now, so there isn't an obvious way we can just cancel 2 things and carry on like before. This one's going to take a little bit more work. The new trick we want to show you with this one comes up whenever there is a square root in an expression, and it involves multiplying the top and the bottom by a conjugate. This is a trick that is not guaranteed to work, but it's something you can try, and sometimes it helps. In this case, if we're trying to get rid of this root, we can multiply the top and the bottom by x plus, because it's a conjugate, root 3x minus 2. You don't change all the signs, just the big one in the middle between the two terms. And if we do that to our numerator, of course, we must do the same thing to our denominator, 3x minus 2. Okay, if we multiply this out, what does it give us? If we FOIL the numerator, we get x times x. We get x times root 3x plus 2, or sorry, minus 2. X root 3x minus 2. Inside, we get minus x root 3x minus 2. And then we get minus, well, it won't be a root anymore, will it? It'll just be 3x minus 2. Because the square root of 3x minus 2 times itself gives simply 3x minus 2. Downstairs, I'm not going to expand this. I want to keep this in pieces because my hope is that we'll cancel that x minus 2, and it'll be harder to see that if I roll it up with a bunch of other terms. So I'm going to keep this in factored form, no changes. X plus root 3x minus 2. Now let's clean up that numerator and see if anything wonderful happens. Well, this is nice, and this happens every time you do a conjugate. The two middle terms cancel out. We had plus x root 3x minus 2 and then minus the exact same thing. Then we get x squared minus 3x plus 2 over all the aforementioned stuff. Well, I was hoping to get an x minus 2 out of there and didn't happen, but this is a quadratic. I guess that should mean it's factorable. If we factor it, we get, oh, look at this. X plus 2, x minus 2, x plus the exact thing that we needed to cancel cancels. And now our reduced expression, x minus 1 over x plus 2, and then x plus root 3x minus 2. We can now try this again and say, hey, now that the piece of you that didn't like 2 is gone, what do you say? 2 minus 1 over 2 plus 2, 2 plus root 3 times 2 minus 2. Sorry, hurting for space. I'll try to fit all this in. 1 over 4 from the first piece. 3 times 2 is 6, minus 2 is 4, square root is 2, plus another 2 is 4. I believe this comes out to 1/16. And that's your limit. So factoring is definitely your friend, and we had to do some of that in this problem. The new trick, if you see a square root, try hitting it with its own conjugate. Often that will produce some cancellations that you need and allow you to make some progress.